Okay, here we go with our second round of notes. Hopefully this microphone works a little bit better and will not hear me breathing so much. Anyway, these are again notes. We are in the geometry book, so they should all be blue. Module 1, Topic 1, Lesson 2. And do not forget to put your name on your notes. That way, if they happen to fall out of your notebook or your binder or anything like that. We're not really going to be doing much on this first page here. It has a warm-up and some learning goals on it, but we kind of need to get going. I don't want these notes to be too long, so we're just going to skip right to the next one. All right, a couple of key things that I want to point out here. Okay. There are some things we're going to learn today, basically how to do some constructions. So we need to make sure that you understand the difference when you're asked to do something. All right, there are times when you are asked to sketch a geometric figure. All right, you do that without tools, and accuracy is not important. So it's just when you like a quick sketch on a napkin or something like that when you're just trying to do it. All right. Then you are asked to draw geometric figures. Now you can use rulers, protractors, okay, a coordinate plane, that sort of stuff to get exact lengths and areas. So that's when you would use a ruler, protractor, and that. Then, okay, you are asked to construct, and that's what we're going to actually do today. We're going to actually construct something. And when you construct, you create exact figures, okay, using a compass and a straight edge. Okay, so it's not just kind of measuring something and getting close. It does say paper folding, but I mean, how often do we really sit there and get into paper folding and that? Okay. All right, so a compass, remember, is a tool that is used to create arcs and circles. A straight edge is a ruler with no numbers. People also call rulers straight edges, but a straight edge can be anything, you know, a side of a book, anything like that. It's just something that you can use to draw that has a straight edge. Okay, so we are going to construct geometric figures in this lesson today. So again, when you sketch, it's without tools. Accuracy is not important. When you draw something, you can use rulers, protractors, coordinate plane to draw exact lengths and areas. Construct means that you use a compass and a straight edge. Now, drawing and constructing are often interchangeably used. As you can see, I mean, draw, you're going to be exact lengths and areas. Construct, you're going to be doing it. Construction uses a compass. Drawing uses coordinate planes. Okay, so we are going to get into how to construct a perpendicular line. A couple of things here. When you are doing this, we need to talk a little bit about notation. In Mathia, you're going to be dealing with notation a little bit this week. So we need to talk about and make sure that we understand that a line is described as a straight and continuous arrangement. A line has infinite length but no width. When we draw a line or construct a line, ours has width because we live in this place called the real world and we have to use something to draw it. But in essence, a line has infinite length and no width. Okay, and you also don't say a straight line. A line by definition is straight. If it's not straight, then it's a curve. Okay, the notation for a line is capital letters denoting points that are on the line. I'm just going to say line AB with a line on top and arrows on both ends. It does not matter if you fill in the arrows or the solid arrows or anything like that. It has to have arrows on both ends. Big thing too, capital letters. Okay, anytime we talk about a point or a vertex, vertice, anything, we're talking with capital letters. You'll find that out in Mathia. It will not accept lowercase letters in some instances. Okay. A line segment is part of a line between 2 points on the line, and they are called endpoints. The notation for that, again, the 2 endpoints with just a line across the top, no arrows. Okay, so this would be line segment AB. And then a point described simply as a location. A point in geometry has no size or shape. Again, we have to represent it, so we use a dot. But when you're talking about something, you talk about point A to point B. You're not talking about specific like dots on the ground or anything like that. So notation, they'll just do that. Sometimes they'll just write it out and say point A. Another one that comes up in Mathia is not brought up here is array. Array is what has one endpoint and then goes off in the opposite direction to infinity or for an infinite measure. So technically a line is considered 2 opposite rays from a single endpoint. But the definition, or the notation I should say, for array is that. And ray AB is different than ray BA, whereas line segment BA, if I was to do this, these 2 line segments are the same. Ray AB and ray BA are 2 different line segments. I mean, rays. So it all just depends. The first letter is the end point on the ray. So different letters, different endpoints. Okay. All right. So just some basic notation. You're going to get some more practice with it with Mathia, and we will touch base on it. Geometry happens to be one of those things where it's very important with notation. It's kind of like when you start learning how to write paragraphs and sentences and all that sort of thing. You always got to capitalize, always have to have, the finger spaces in between and that sort of stuff. Notation at the end, period, question mark, whatever. All right, only other thing I really want to touch on this page, and right now we're on page 20. So a lot of pages, not hitting much on it, because really the big thing today is learning how to construct a perpendicular bisector and how to construct a duplicate line. So we're just kind of getting through some notation and some information here. So a midpoint of a line is a segment, or is the point that divides the line into 2 congruent segments. So congruent means equal. Congruent is used in geometry when we're talking about congruent figures and we're talking about specific size and shapes. Equal denotes measure. So you can actually measure something. Okay, so there's a little bit different there. Congruency is when you discuss actual shapes and size. Equal is when you're talking about measurements. Okay. All right. And then last little thing here. So again, a midpoint is the point on a segment. I should point that out as well. You cannot have a midpoint on a line because a line goes on for infinite. So a midpoint is the point on a line segment that divides the line segment into 2 congruent or equal segments or measures. Okay, a segment bisector. This is what we're getting into. A segment bisector is a line segment, or array that divides a line segment into two line segments of equal length. All right? A basic geometric construction used to locate a midpoint of a line segment is called bisecting a line segment. So we're going to kind of learn how to do that by making a perpendicular bisector. You don't have to, when you make a perpendicular line to any segment, when you construct one, always make a segment bisector, but this book tends to always kind of go down that road and that sort of thing. So basically a segment bisector is a line segment, or array that divides a line segment into two equal lengths. Okay. So to find the midpoint of a line segment, you're actually bisecting that line segment. Okay. All right, so we are going to get into actually constructing a perpendicular line through a point using a compass and a straight edge. Now I'm going to do this hopefully on the smartboard and it'll work well. We'll see. Sometimes it does, sometimes it doesn't. There is a worked example here, so you're more than welcome to read through the work example. I am going to just do it, and but you can have this. Also in the Blackboard is a video that does it a little bit differently than this. So if you watch the video on how to construct a perpendicular line bisector, then you may, you'll see a little bit different. So I'm just going to kind of go down here. So you need to have your compass, okay, with you while you're doing these notes. So we are going to construct a line perpendicular. Now we don't know for sure that this is going to be the perpendicular because it's a line. So it's not going to be the perpendicular bisector of this line, because you cannot construct a perpendicular bisector of a line. You can only do it of a segment, which means that you need to basically find 2 points. The first thing you need to do is find 2 points that are equal distance from the point you want your line to go through. To do that, you need a compass, and they always, for some reason, put the compass at the top of the page, so I got to kind of scroll down to bring it. Now I've got this massive compass here. Okay. So the first thing that you need to do with your compass is you need to find 2 points that are equal distance from P. Well, you can't measure it, you have to construct it. So that means you need to get the pointy end of the compass onto point P. Then your compass is already opened up. Mine on here is not opened up at all, but yours is already opened up. You want it to be opened up enough so that it's far enough away from P that you can get some good accurate measurements, but you don't want it so far that it makes it almost impossible to do. So it doesn't really matter how far, but you don't want it so close that it's hard to draw a circle, and so far away that you go off of the line. So basically we are just trying to find 2 points that are equal distance from P. Now mine automatically makes a full circle. I can't sit there. Well, let's see if I can do it. So I'm going to sit here and just construct a little arc right here. And then I'm going to flip it over to the other side. Now I haven't moved anything. All I did was, so my pointy end is still on P, and all I did was just flip it around, and I'm going to draw a little arc on this side. Now if I wanted to, I could continue. Whoops, now I moved it. Let's see if I can get it back there. I could continue and just draw a circle all the way around. It starts getting messy if you do that, so you don't have to. Let's see if I can erase that now. See if it'll let me. No, it won't let me erase it. So you can just stay with the 2 arcs, or you can draw a complete arc around, or a semicircle around. Okay. Now that I have 2 points that are equal distance away, okay, I'm going to put little dots on those points. Just makes it a little bit easier to put the pointy end on the dot. You don't really have to do that, but it does make it a little bit easier. And then I am going to move my compass so that my pointy end is at the intersection of that line and that dot. Okay. Now, I'm going to see, can I change? I'm going to change my color. We'll see if it works or not. Okay. Oh, it does. All right. So now I am going to, I'm going to do this around like this. I have to extend out so that I'm past that point, because I want the line to go through that point. So I have to extend out. So my pointy end is on one of my new points. I now know that this line here and this line here are congruent. They're equal distances from P. So I basically have made a segment here. If I wanted to label it, I could label it AB. So P is the midpoint of AB. I'm going to put my pointy end back on there. I have to sit there. Those little hash marks that I just put there means that the distance from P to A and P to B are equal or congruent. So that's all that those mean. So what I'm going to do is I'm now going to construct my compass. Pointy end is on point B in this case, and my pencil end is past point P. All right. I'm now going to construct a circle all the way around point B. And then I'm going to pick my compass up again, put it on point A, and I am going to construct a circle. I have not changed. When I picked up my compass, it is still the same distance that it was from B to my circle of A as from A, or circle of B to A to the circle I'm going to make. So I did not squeeze or do that. If you did accidentally move or it moved, then you need to go back, measure again from B, and make sure that that distance from the pointy end to the pencil end matches. So that's why you always need to make sure that your compass is somewhat tight on the, and doesn't flop around. All right, so now I'm going to make another circle all the way around A. Now I don't need my compass anymore. Let's see if it'll go away. There we go. I don't need my compass anymore. So now you can kind of see I have 3 points here. This point right here, this point right here, and this point right here that somewhat line up. Okay? So I am going to drop a line, grab a straight edge and drop a line. I mean, I'm not going to use a straight edge. You will use a straight edge or a ruler. Okay? And I'm going to drop a line from this point all the way through this point. And I'm off a little bit just because I'm doing this on the smart board. Okay? But hopefully it's pretty close. It goes through the 3 points and that. Whoops. Okay? Now you have just constructed a perpendicular line, segment, I should say. Oops, not that there. Where's my pen? There we go. A perpendicular line to line P, and it happens to bisect line segment AB. So again, the steps on doing it: first, you have to draw an arc to get 2 equal points away from P. Then you move your pointy end over to, so basically you stick your pointy end on P and you draw an arc on the line to where it intersects the line P. Label those, whatever you want to label them. I labeled mine A and B. You then pick your compass up, put the pointy end on one of those points. I started off with B. I dragged out my compass to where it was large enough and went past point B. I drew a circle around point B. Keeping that same distance, I then picked up and put the pointy end on A, drew a circle around A. Where they intersect is the perpendicular line to my original line of P. Okay? You will get more practice on this, okay? So don't worry about it if you're kind of struggling on it right now. Okay? All right. Now, this next example is just doing basically the same thing, but now the point is not on the line. Doesn't matter whether it's on the line or off the line, you do the same exact thing. Okay? First thing I need to do is I need to get a compass. And again, for some reason, this thing drops it off at the top. I have to bring it down. Okay, so I have it down here. This time, because point B is not on the line, I still have to start with point B, so I have to put my pointy end on point B. And I have to construct an arc from point B that intersects line L. So I'm going to stretch it out just a little bit. I don't want to go too far so that it's off the line. I also don't want to go too close to where it doesn't even hit the line that way. So I want to just kind of go right here. Okay. I am going to just draw an arc right there. This time I'm not going to do a full arc because you could see where it kind of got messy. So now I've kind of drawn an arc where it intersects the line. I'm now going to pick my little pencil, keeping the pointy part on B, and I'm just going to flip it over to the other side, and I'm going to draw a little arc right there. Okay. Now I have my intersecting arcs with the line L, so I just pick my compass up, I put it on where those two intersect. I stretch my compass out a little bit. I'm going to change colors here just so that it gets a little bit easier to see. And then I am going to draw a circle around the point that I have created on line L. So I'm just going to draw a circle around here. Pick up the pointy end. Get it as best I can. Again, remember, don't squeeze or squish or pull it out. You want it to be the same size circle that you just created around your one. And then I am going to draw a circle around this one. Now I don't need this anymore. Put it up over here. It's not. There we go. Ah. All right, now I just need to drop a line through. So hopefully, if I have a decent line this time, I can start at the intersection point here. And it goes through pretty close. It's kind of hard with this, with the smart board, but it draws a line through pretty close to B, and that is perpendicular to that line. Okay, and actually I have bisected this little line segment in here. So this distance here is equal to this distance here because I drew it based off of that point B. So I could say, if I wanted to, again, if I wanted to label this point A and point C, since I already have a point B there, I could say that the distance from A to, we'll just call this point X, A to X is equal to C to X. All right. All right, so you're going to get a little bit more practice on that later on. We now need to get into how to duplicate a line. And we're actually going to do that on, we're going to look at it on page 25. See if I can get to it here. All right. So, whoops. So here is the way to do it. And I think that this explanation looks a little kind of crazy to do. So I'm just going to kind of talk about it. So basically you can duplicate a line. So it starts off, you're given this line segment AB, and you can't really duplicate a line. I should have said line segment, sorry. You just a line would just go on. You just put arrows on the end. But you kind of start here, and then you draw another line. And then you go up here. You kind of ignore this part down here. And then you end up going down here. So if you're looking at this worked example, it makes it look 10 times harder than constructing a duplicate line. Okay, so you can look at it, but it really is a lot easier than it seems on that worked example. All right, so we're going to construct one real quick, and then we're basically going to be done. All right, Jan and Jackie kind of do an interesting way about it. It's seriously just as easy as what we're going to do right now. We're going to duplicate WX, I mean. Okay, so all you need to do, to duplicate a line, you need to make a line. So I need to just have a line. So use a ruler, whoops, just one line, not two. Come on. There we go. All right, so I need to duplicate it. Okay, so here I have this line segment. Okay, I am going to put a little dot right there, and I'm going to call this W prime. That little prime symbol, or that little looks like an exponent 1, means that I'm duplicating WX, and I'm going to start off with point W, but it's not point W, it's actually a copy of point W. It's called W prime. Okay. Then I need my compass, and of course it puts it way up here, so let me bring it down. And then on my compass, I have to stick the pointy end where the W is. Okay, then all I'm going to do is I am going to, and I have to kind of rotate this. It's going to need, it's a little bit, there we go. Let me get this back on pointy end. And then I need to rotate this to where the pencil like I said, sometimes the compass works for me, sometimes it doesn't. Where the pencil is on the other point. So pointy end is on W, pencil is on the other point. Then you do not touch it. You don't squeeze it. You don't make it bigger, because basically what you're doing is you're just measuring out the distance from W to X. This is if you ever watch those movies and they do that thing on the maps, and when they're doing old ships and stuff, this is kind of what they do. They're measuring out distances and that sort of thing. But anyway, so now I'm going to take that exactly same distance. I'm going to put my pointy end on W prime. And then I'm going to come down here and I'm going to draw an arc through that line segment in this case. I then get rid of my compass, delete, come on, delete, there we go. All right, and now all I have to do is label this intersection point X prime, and I have just duplicated the line segment WX onto W prime X prime. So it's one of the easiest things. The steps basically, you draw a line segment, you label one end of it, one of the endpoints of what you're trying to copy. You put your pointy end on the one. So in this case, I put my pointy end on the original W, measure out to the original X. Don't change that, and I bring it down and put my pointy end on W prime. I draw an arc, and I make X prime. All right, so those are our constructions. Okay, that last construction was on page 26. Okay, and that is it for the notes.